We talk about saving annuity. Now let's look at the payout annuity. Payout annuity is annuity where money is already in an account and withdrawals are made over period of time. So payout annuity, the formula is quite different. And the parameter, using in this formula, very similar as saving annuity, except this is the present value, instead of future value, or is initial value of the annuity. PMT in this case is the withdrawal amount instead of the deposit amount. RKN is the same as saving annuity. All right, now let's look at an example. A donor gives $100,000 to a university and specified that it is to be used to give annual scholarships for the next 20 years. If the university can earn 4% interest, how much can they give in scholarship each year? And round the answer to the nearest cents. So what we are looking for, how much can they give in scholarship each year? So in the parameter values, which one we're looking for? Or in other words, what type of annuity this is? We have this much money, right? And take it out as scholarship every year, right? And for the next 20 years, so we keep withdrawing annually, right? So this is a payout annuity, and what we're looking for is the withdrawal amount. Think about, is that right? And in this case, 100,000 is the initial annuity value, right? R 0.04. K, what about K? Annually, so K equals 1. N, this time, is 20 years. Think about, does that matching your expectation? And then payout annuity formula, PV equals PMT times parentheses 1 minus parentheses 1 plus R over K raised to negative NK power. All right, and then close parentheses, that's numerator, denominator R over K. And then we're looking for payment. So again, we need to derive the formula, solve for the payment, solving linear equation again. So in order to cancel out right-hand side, right, this part, this whole thing, we need to multiply its reciprocal. In other words, we need to time R over K on both sides of the equation, and then divide 1 minus parentheses 1 plus R over K raised to negative NK power. Both sides of the equation divided by this. All right, and then so the new formula is, this and this cancel out right-hand side, right? This and this cancel out. So right-hand side, we only have PMT. Left-hand side, we have PV times R over K, right? That's numerator. Denominator is 1 minus parentheses 1 plus R over K raised to negative NK power. And then close. Denominator outer parentheses. And then we can plug in the parameter value, right? Withdrawal amount equals PV, that's 100,000, times R, that's 0.04 over K, K equals 1, right? Divided by 1 minus parentheses 1 plus 0.04 divided by 1. I don't have to do this divided by 1, but in order to show you the process, I'm still writing it there, okay? But when you put in the calculator, you don't have to do multiply by 1 or divided by 1. It's just the same. And then if you put this formula into the calculator, which is I show you another video, okay, that's $7,358.18. That's the answer. All right, now we put the formula in. Numerator, 100,000 times 0.04 divided by 1, right? Divided by 1, I don't have to put it divided by 1, okay? Because I know it's the same. And then that's numerator divided by outer parentheses 1 minus inner parentheses 1 plus 0.04, again divided by 1, okay? I don't do that. And then close inner parentheses raised to negative, okay, negative 20 times 1 power. This is a negative sign, okay, negative 20 times 1. I know it's going to be the same, so I just ignore times 1, okay, and then bring my cursor back to the normal position, close the denominator's outer parentheses, and then press enter. That's my answer. Okay, and then round it to the nearest cents, right? Place the back door after 7. So my answer is $7,358 and how many cents you think? 18 cents. Is that right?